In this set of class notes, we're going to continue to look at hyperbolas. And what I'm going to do is I'm going to skip over example 1 for now, and then I'm actually going to stick this at the end of this video. The reason is because example 1's a really neat one. It shows you a cool application of hyperbolas. And so I hope you will check it out and kind of follow along with it as I go through it. But I'm going to save it for last because I'll just level with you that it's kind of beyond what I would expect you to do on a test, even at the expert level. And so I want to start with the things that are going to be really relevant to the homework you're doing right now, and then we can save this fun one for last. All right, so just like with ellipses, the class notes focus on what happens if we move our conic section to a place where it's centered not at the origin but at some other point. And so here is just a picture of a shifted hyperbola that has a center of HK, right? So it's going to have this formula up here. And then there's a whole bunch of other formulas. Remember with ellipses, what I said was don't get bogged down in trying to memorize formulas. Just understand that the A, B, and C that you're used to from the video notes are just now going to be played off of this center as opposed to off of 0, 0, right? So we're doing the same process, but you just kind of have a different home base essentially to start with as you graph the parts of these hyperbolas. And then here's, of course, same idea here, but this is the one where the branches are opening up and down instead of side to side. And just as a reminder, right, in the equation you can see this when the positive one is y, like up here, that's when you're opening up and down. When the positive term is with the x, then that's when you're opening side to side. All right, so let's take a look at example 2. In this one, they throw a whole bunch of points at us and say, all right, find the hyperbola. In other words, find the equation. So even though it's not specifically asking me to graph, like with ellipses, remember that it can be helpful just to sketch a very rough graph. And so I look here, and it looks like I'm sticking with x equals -1 throughout all these points, but I've got a lot of variety in the y values. So I got to get myself all the way up to 13 and as low as -5. So that means that I should make tick marks that are pretty close together. Since there's so many, maybe I will go ahead and label them as I go. So there's a 5, 6, 7, 8, 9, 10, 11, 12, 13. I guess that's as high as I need to go. And then down 1, 2, 3, 4, 5. And I think that'll cover it, because then all the rest of it, if I put x equals -1 right there, all the points are on x equals -1. So I have a center at 1 or -1, 4. So that puts me right there. I have vertices at -1, -3. That puts me there. And at -1, 11, that puts me there. And then foci at -1, -5, -1, 13. All right. So you can see what's going to happen here, and we can even sketch this, because we're not trying to be super accurate here, but just to kind of visualize what we're creating. This is going to be one where the hyperbola is opening up and down because of where the foci are, where the vertices are, and how they're lying along this transverse axis that is vertical. So what I can definitely do right off the bat is I can say that the y term is going to be positive and the x term is going to be negative. Right? So as I build this thing, I can just pencil that in right away. And I can pencil in the center, of course, right? So we know that the center here is -1, 4. So that means we can say x -1, and we can say x plus 1 and y minus 4. Okay, so we know that all we got to do here is we got to find A and we got to find B. All right, well, we know A. Okay, if we know where the center's at, then A is just this distance here that's going from the center to each vertex. And we can see that that is a distance of 7 in both cases. So that means A is equal to 7. And so, of course, A squared is 49. So that means we can put a 49 underneath of the y term. All right, well, we want to know what B is. So B, of course, is going to be how far you go out this way and that way to make your construction box. Or another way of putting it is it tells you how much to go this way and that way in order to make the slope of your asymptotes, right? But this is all built off of the fact that we know c squared is equal to a squared plus b squared. So I know a squared is 49, that's no problem. So do I know c squared? Yes, I do, right? Because I can take this distance from the center out to the focus, which would be 9 in both cases, of course. So that must mean that c squared, c is 9, so c squared is equal to 81. So I have everything I need to be able to solve for b squared. So b squared is equal to 32, and so that means I can stick a 32 right there. And that'll be the equation for the hyperbola that fits this particular description. All right, so looking at another example, number 3. So this one wants us to find the equation of the hyperbola with those two foci, and that passes through the point 3, 2. All right, so again, it can't hurt us just to sketch a real simple picture at least. All right, so we've got -2, 2 and 4, 2. So both of them are up 2. Okay, so I can put a point right here and put a point right there. Those are the foci. Now, the fact that they're both lying along y equals 2 means that y equals 2 is that transverse axis, right? So these are going to be side opening hyperbolas here. And so right off the bat, like in the last one, I can immediately say, okay, I'm going to have x, right, over a squared minus y squared over b squared is equal to 1. Okay, so do I know my center? Well, sure I do, right? The center's always got to be halfway between the two foci, right? So if I count 1, 2, 3, 4, 5, 6, right? These are 6 apart, so that must mean the center is 3 away from this one and 3 away from that one. So that puts us at 1, 2. So I can say x minus 1, y minus 2. All right, and so what's our task now? Our task is to figure out what a squared and b squared happen to be. All right, so what's the piece of information we haven't used yet? Well, we haven't used the piece of information that it's passing through the point 3, 2. So we're going to go 1, 2, 3 up 2. So that means this is a point on the hyperbola as well. So at this point I can graph this, and the nice thing is if it is on the transverse axis, then we know that that distance from the center out is actually my a, right? Because of how we construct hyperbolas. So with a being equal to 2, we know a squared is equal to 4. And then, of course, we use our equation, c squared equals a squared plus b squared. So we have, well, we know c, right? Because c's distance from the center is 3. We know c equals 3, so c squared equals 9. So we have 9 equals 4 plus b squared. So b squared is 5. Which of course b is root 5, but the most important part here is that we've got the equation because that's what it asked for. So x minus 1 squared over 4 minus y minus 2 squared over 9. Oh, excuse me, not over 9, over 5 is equal to 1. Now we ran into some problems with ellipses where they didn't give us our equation in the way we want it, right? In that x minus h squared over a squared minus y minus k squared over b squared equals 1, right? And so that's what example 4 is asking us to do, is put the equation of this hyperbola into that standard form, and then, based on that, go ahead and sketch the graph. All right, so remember our task in a problem like this is to complete the square for our variables. And as we talked about with ellipses, that task starts by getting the x terms together and getting the y terms together. So I'll just reorder things. X squared minus 2x minus 5y squared plus 20y is equal to 44. And we remember that if we have a coefficient besides 1 in front of our x term, or x squared term, or our y squared term, we want to factor that out. But we're only going to factor it out of those variables. So if I look at x squared minus 2x, there's already a 1 here. So I'm actually quite happy with that. So I'm just going to rewrite it. But then I'm thinking ahead to say, you know what, I know that I'm going to end up completing the square for these x terms, so I know that I'm going to add something to it, right? And then over here, we have negative 5y squared. Well, I want a 1 in front of my y squared, so I'm going to factor out a negative 5 so that I have y squared, and then of course what I would have here is minus 4y plus something, right? And that's equal to 44. But of course this stuff that we're adding over here on the left side, I can't just do that. I would have to also add it on the right side. So I need to add what's in red there. And I need to add, and we got to be careful here, we actually have to add, and I'm going to put it like this actually, plus not just the green blank, but negative 5 times what's in the green blank, right? Because ultimately that gets multiplied by negative 5. So the number that's here is not exactly the same as what you need to add to the right side. All right, and then we can go about this process. So what do I put here, right? Well, we chop the middle coefficient in half and square, chop the middle coefficient in half and square it. So that's what I'm putting over here as well. So I get x squared minus 2x, and that's just going to be plus 1. Minus 5 times y squared minus 4y, and then divide that by 2, square it, so that's going to be plus 4. And then 44 plus 1 minus 5 times 4. But that puts me in a position to be able to factor this, and it factors into x minus 1 squared. This factors into y minus 2 squared. And that's equal to, well, we have 45 minus 20, so that would be 25. So we're almost home free here, but what do we need? We need to have this equal to 1, right? So the last step is to divide everything by 25. And so with that, since I'm pretty much out of room, I guess we'll go ahead and write it here at the bottom. X minus 1 squared over 25 minus y minus 2 squared over 5 is equal to 1. So there's my equation, okay? But the other thing it asked me to do is to sketch a good graph of this. All right, so let's work on that. I'll rewrite this up here. So this will be x minus 1 squared over 25 minus y minus 2 squared over 5 equals 1. All right, so what does this tell us? Well, first of all, it tells us where the center is, right? So the center is at 1, 2. So I'm going to go over 1, up 2. I'll go ahead and finish some of these tick marks out. All right, so there's our center. Go ahead and keep track of what we're discovering here. Center is at 1, 2. All right, well, what else do we know? Well, we know that a squared is equal to 25. So that means a equals 5. So from the center, I go 5 in both directions to come up with my vertices. Okay, which direction do I go though? Well, I go in the direction of whichever variable term is positive. So we can say we'll go 5 from center in x direction. So here, 1, 2, 3, 4, I guess we're going to need a 5 right there. And then 1, 2, 3, 4, 5. Right? Okay, so that's good. All right, we've got b squared is 5, right? So b squared equals 5. So that means b equals the square root of 5. So b, let's go ahead and get an approximation here, is about 2.2. All right, so what does that mean? We go up b, right? This won't be an actual point on the hyperbola, but it will help us draw that construction box, right? So we'll go up about 2.2 from there, and go down about 2.2. And that's how we're going to draw that box. So now that I've got my A's and my B's, we can sketch this box in here. And of course, that allows us to accurately sketch our asymptotes. So from corner to corner, sketch that slant asymptote that my hyperbola is going to follow. I didn't think ahead enough on my scale here. Didn't leave myself in that much room. So perhaps when I go to graph this, I should use a different color. All right, so it's almost all there. It's almost ready to graph, but we do want to also graph our foci, right? And of course, our foci, remember, c squared is equal to a squared plus b squared. So that's 25 plus 5 is 30. So c is equal to the square root of 30, which is about 5.5, right? So remember, we went out 5 to get to the vertex, so 5.5 is not that much further. So there's my foci right there. And so that allows me to get this thing sketched. I know that it's got to approach those asymptotes. So I'll make sure that that's what I'm conveying as I sketch this hyperbola. All right, let's do one last example. similar to the last one, so I would suggest giving this one a try on your own. So pause the video, try to come up with the equation and the graph for this one. All right, so hopefully you give yourself a chance to work that out. So let's check to see how we did. So first of all, we're gathering our x terms together and our y terms together. In this case, there's just a y squared term, and that's it. And then I moved my number over to the right side, right? Just to get that out of the way. I just want x and y terms on this side. With the x terms, I want to factor out a 16 so that I can have a positive 1 in front of my x squared term. And of course, I'm going to add something so that it's a completed square. And then this is already a completed square, right? It's y minus 0 squared. So we leave that one alone. So now we just have to remember on this right side, okay, yes, I want to add this red blank, but I really want to multiply it by 16 also. So it's plus 16 times what's in the red blank there. All right, so we know that we want to add half of that middle term squared. Okay. And then we've got right here x squared minus 6x, and that's going to be plus 9 minus 9y squared. And so 16 times 9 is going to be 144. So negative 288 plus 144. And as I factor this, we have 16 times, this will be x minus 3 squared minus 9y squared equals negative 144. Now be careful here. We know that the very last step is to make sure that 1 is on the right side of this equation. So don't just divide by 144, you've got to divide by negative 144 because it's got to be equal to positive 1. And so now what I've got here is when you've got 16 on top, 144 on bottom, you want to reduce that. So divide by 16, you get 1. Divide by 16, you get 9. Divide by 9, you get 1. Divide by 9, you get 16. Here, we introduce this negative. So now it's negative x minus 3 squared over 9. And over here, it's positive, negative on top, negative on bottom. So positive y squared over 16 is equal to 1. So now let's see how that turns into our graph. All right, so once again, negative x minus 3 squared over 9 plus y squared over 16 equals 1. All right, so first of all, notice that this is going to be this type of hyperbola, right? Because the y term is the one that's positive this time. All right, and then of course our center, we can see, is 3, 0. So I'll go over 1, 2, 3, 4, 5, 6. So 3, 0 puts our center right there. All right, and then we can see a squared is equal to 9, so that means a equals 3. Excuse me. B squared is equal to 9. Sorry about that. B squared is equal to 9, so B equals 3, right? And then a squared is equal to 16, so a equals 4. So that means I've got to go 4 in the y direction away from center, and on both, of course, both directions. So that puts a point here and a point here. And then for B, I've got to go 3 both ways in the x direction. So there's B from center and B from center. So this is going to give me my box. which in turn gives me my asymptotes. Only thing left is to draw the graph, but also the foci. So c squared is equal to 16 plus 9, which is 25. So that means c equals 5. So down one more here, there's a focus, and up one more here, there's a focus. And so that means here's my hyperbola. And in this first example, I just want to give you an idea of what's a kind of a neat application of our study of hyperbolas. And I'll just tell you right off the bat, this level of problem isn't one that I'm going to be expecting you to do on a test, but it's a neat problem, so let's take a look at it. So it says that a ship is traveling on a course west to east. That is 100 miles from and parallel to a straight shoreline. The ship sends out a distress signal that is received by two Coast Guard stations A and B, and those are located 200 miles apart. By measuring the difference in signal reception times, it is determined that the ship is 160 miles closer to B than to A. Give directions to the ship from station B. All right, so you might wonder, what in the world does this have to do with hyperbolas? What it has to do with hyperbolas is, remember from the video notes the definition of what a hyperbola is. A hyperbola is all the set of points that if you took the distance from that point to one focus, and then the distance from that point to the other focus, and subtracted them, it's the entire set of points for which that difference is constant. Okay, so let's put that in a picture. So let's say here's a point on the hyperbola. So what we're saying is that if you take this distance here, make it solid, right? So you take that distance there from this focus to a point and this focus to that point, and you subtract them. So the difference is constant for each point on the hyperbola. That's how we define a hyperbola. And we didn't go into great detail with this in the video notes, but that's just a reminder that that's what it is. So how does this apply to what we're doing here? Well, what they told us is that we are 160 miles closer to B than to A. So if I label this focus here B, right, the station B, and this one station A, what we're saying is that the difference from this point from the ship to here, and the difference with the distance from here, is equal to 160. We'll just say it like this. Difference in distances is 160. So if I label these foci as these stations, we can also label the fact that we know that they're 200 miles apart. So if A and B are 200 miles apart from each other, then we also know that the distance from here to here is 100, and the distance from here to here is 100. All right, so in other words, we know that C is equal to 100. And let's bear in mind that we know C squared equals A squared plus B squared for hyperbolas when we're thinking in terms of x squared over A squared minus y squared over B squared equals 1. So here's the idea. if I'm assuming that this ship is on a hyperbola of some sort, then if I can figure out this equation, I should be able to solve for my variable. In this case, it's definitely going to be my x, right? Because remember that the other thing that they told us, right, is that we're 100 miles offshore, right? So we already do know that this is 100 miles, right? So in other words, we know what the y value is. All right. So what we want to do is get to work trying to figure out what A and B are. Okay. So we know C, that's great, but we don't know A, we don't know B. So how are we supposed to make any progress here? Well, let's remember what we said over here. The difference in distances is 160. So that goes for a point here, but guess what? It also would go for a point, say, right here, a nice easy point. So if we look at this yellow point, let's think about, okay, how do I figure out the two different distances, right, to these foci? Well, let's start with this small distance here. So this little tiny distance, what's that? Well, I know it's 100 from the origin out to the focus. It's a distance of A from the origin out to our point. So it looks like this little yellow distance would be 100 minus A, right? Okay, but then we also need to figure out the distance from this point over to this other focus. So let's draw a blue line there. Okay, so what is that distance? Well, this from here to here is 100, and then from there to there is A, so that's 100 plus A. Now this yellow point is another valid point on this hyperbola. So what do we know about it? We know that because the distance's difference is 160, we also know it's 160 for these two distances when we subtract them. So 100 plus A minus 100 minus A is equal to 160. And this will tell me what A should be. So 100 plus A minus 100 plus A. So we get 2A is 160. So that must mean A is equal to 80. So I can update my formula here to be x squared over 80 squared minus y squared over, well, we can easily find B because of the formula we know for hyperbolas, which is c squared equals a squared plus b squared. So that means that 100 squared equals 80 squared plus b squared. And so get 10,000 equals 6,400 plus b squared. And so b ends up being a pretty nice number here actually, because we get 3,600 is b squared, and so that must mean b equals 60. So we can put 60 squared down here. Right now, how does that help us? Well, remember, if I go back up to the picture, we already know that the ship was traveling 100 miles, right here, 100 miles from this shoreline. And so I know that the y value has to be 100. So all I've got to do now is solve for x if I plug 100 in there. So let's do that. So x squared over 6,400 minus 100 squared over 3,600 equals 1. And no need to do any serious calculations here. Right? We can just say this is 1 plus 10,000 over 3,600. And then x squared is equal to multiplying both sides by 6,400. 6,400 times this. And so as I solve for x here, x would be the square root of all this stuff. So x is about 155.5 miles when you put that in the calculator. So what that means is that if I want to go from B to where the distress signal was given, which is right here, right? I just need to go over here and up there, right? So what is that going to be? Well, since here to here is 100, then this must be 55.5. So the instructions we would give to the Coast Guard or whoever it was would be to go east 55.5 miles and 100 miles out to sea. Right. All right, so that's an interesting problem. Again, I just wanted to show you kind of a nice application of hyperbolas. There's lots of others, but this is probably not. This is a little bit beyond what I would really be asking you to do on a test, even for like the expert level.